Alrighty, so today we want to have a look at how do we actually compare an individual score in one data set and use that as a predictor to predict our values in the next one. And we're going to be using the mean and the standard deviations. So you can see here the results for a term 1 problem solving test are a bunch of numbers, but Chloe was absent for the term 2 problem solving test, with the results of the others being this. So that's everyone in the class but Chloe. If Chloe's result was the third value, in this case 14, in the first list, use mean and standard deviation to estimate a score for Chloe in the second test. So first thing we need to do is work out the mean and standard deviation for term 1 and for term 2. Now for something like this, we actually can't use both standard deviations, so we're going to be using the sample standard deviation in both of these cases. Using technology, I'm going to work out each of the mean and standard deviations for term 1 and term 2. So you can see I calculated the mean and the standard deviation sample for both of these, and I've rounded to 2 decimal places just for consistency. So what do we want to do? We want to estimate what her score would have been in term 2 if she'd set the test. So the first thing to go is, well, she scored a 14. That's higher than the average in term 1. If you look at the average was 13.43. So she should score above the average in the second test. That just makes sense. If you score above the mean in the first test, you should score above the mean in the second test. So, first one, difference between the score and the mean. 14 minus 13.43 equals 0.57. So she scored 0.57 above the mean. That's nothing crazy. The interesting part is then, how many standard deviations is that? So how many standard deviations did she score above? You can see that the standard deviation was about 4.99. So it was not even one standard deviation above. So she only scored a little bit of a standard deviation above. So how many standard deviations? Well, we do that using division, which is equal to 0.11. 114. I'm just rounding to 3 decimal places here. And so then we've got to ask the question, well, okay, so she scored 0.114, a standard deviation above the mean. Well, her new score, her score for term 2, well, that's going to be the mean, 11.68, plus, because she scored above, the standard deviation, which was 3.40, times by how many standard deviations above she was, so 0.114. And that's going to calculate how much further above she should be. And we get 12.0676, which is not a great answer, because she's probably not going to score 12.0676. So instead we approximate this to 12. So the estimate is 12. And there we go. So you'll notice that essentially what we do is we use the term 1 or the first group's mean and standard deviation to work out how many standard deviations she's above. And then we use the second two, 11.68 and 3.4, to work out what her score is actually going to be. So this is the kind of combination between the two. Alrighty, there we go. I'll see you in the next one. Goodbye.